Welcome to The Explainer. Today, we are strapping in to explore some of the most extreme, terrifying, and, quite frankly, totally incomprehensible objects in the entire universe. We're talking about bodies so bizarre that the normal laws of physics just kind of break down and start sweating when you look at them. So, let's dive right in.
I want you to imagine, just for a second, that you could take a standard kitchen teaspoon, travel all the way across the cosmos, and scoop up just a tiny little bit of a neutron star. Now, what exactly would happen if you brought that seemingly harmless spoonful back here to Earth?
Well, you definitely wouldn't be holding it for long. That single tiny spoonful could weigh up to 6 billion tons. Let that sink in. Because of its absolutely unimaginable density, it would instantly tear right through your hand, plummet straight through the Earth, and break down, releasing as much energy as our entire sun produces in 2 to 3 seconds. So you wouldn't just drop it. It would literally be a planetary cataclysm.
Section 1. Birth of a Cosmic Monster. So, how do we get here? These terrifying cosmic monsters owe their existence to the dramatic death of massive stars. See, a living star is basically a giant balancing act. You've got gravity pulling millions of billions of trillions of tons of plasma inward, while nuclear fusion pushes outward. But eventually, a massive star runs out of hydrogen fuel. And when that happens, it panics. It starts fusing heavier and heavier elements just to stay alive. Carbon burns into neon over a few centuries, oxygen to silicon in months, and finally, silicon to iron in just a single day. But iron? Iron is nuclear ash. It's the ultimate breaking point because it just can't be fused. Suddenly, the fusion stops. Gravity instantly wins the tug of war, and the core is absolutely crushed by the unbelievable weight of the star above it. The entire star implodes. The outer layers rush inward at a staggering 25% of the speed of light. This incomprehensible mass hits the solid iron core, bounces off, and triggers a massive shockwave that blows the rest of the star out into space. This is a supernova, an explosion so insanely violent it can outshine entire galaxies. And that crushed, leftover core sitting in the dust, that is our newly born neutron star. Section 2. Gravity and Extreme Density.
Now, what remains in that leftover core is roughly 1,000,000 times the mass of the Earth, all compressed into an object about 25 kilometers wide. That's basically the size of a single city. To understand this, we really have to look at the difference between mass and weight. On Earth, if your mass is 70 kilograms, you weigh 70 kilograms, thanks to Earth's gravity. But on a neutron star, the gravity is roughly 200 billion times stronger than on Earth. So your mass stays exactly the same, but your weight would be 200 billion times greater.
The density here is so mind-bending, it literally defies human logic. If you took all the living human beings on planet Earth and crushed them down, they would fit into a single sugar cube of neutron star matter. Actually, put another way, the density is equivalent to cramming the entire mass of Mount Everest into a standard cup of coffee.
So what if you actually tried to visit one? Let's send in a hypothetical galactic crash test dummy. We'll call him Chuck. As Chuck nears the star, he's accelerated to half the speed of light. When he's about 150 miles above the surface, gravity pulls on his body with such intense, uneven force that the results are, well, horrific. Within the literal blink of an eye, his joints are violently dislocated, his skin is ripped off, and his bones and organs are pulled completely apart.
You might have heard of the elegant concept of spaghettification near black holes, where extreme gravity stretches you out like a noodle. But reality here isn't elegant at all. Chuck is literally shredded into a thin stream of individual atoms. Those atoms hurtle into the perfectly smooth surface of the star at 100,000 miles per second. The impact triggers an explosion that completely dwarfs the entire nuclear arsenal of planet Earth.
Section 3. Inside the nuclear pasta. Now, assuming you somehow had a magical suit that stopped you from becoming a nuclear explosion on the surface, let's dive below that 1,000,000 degrees Celsius iron crust and descend into the absolute strangeness of the star's interior. As we push deeper, the crushing gravity forces protons and electrons to literally fuse into neutrons. By the time we reach the base of the crust, the pressure is so intense that the nuclei actually start to touch and overlap each other. They rearrange into enormous, continuous structures shaped like long cylinders and flat sheets. Physicists actually call this state of matter nuclear pasta. And because it's packed so densely, This bizarre cosmic spaghetti might just be the strongest, most unbreakable material in the entire universe. Because this material is so dense and rigid, the surface of a neutron star is likely a nearly perfect, flawless sphere. But occasionally, imperfections do form. Lumps of this unbreakable nuclear pasta can push up to form tiny little mountains. Now, these mountains might only be a few centimeters high, yet because of the star's insane density, that tiny little bump on the crust weighs as much as the entire Himalayan mountain range.
Section 4. The strange matter contagion. As we plunge even deeper, right into the absolute core of the star, the normal rules of atomic physics completely throw in the towel. They just break down entirely. At the very heart of the star, the pressure reaches a maximum level of bizarreness. It's believed that down here, protons and neutrons might completely dissolve into an ocean of subatomic particles called quarks, creating what's called a quark-gluon plasma. And within this soup, some quarks might convert into what scientists literally call strange quarks. This forms a highly theoretical substance known as strange matter. And what's truly terrifying is that strange matter isn't just weird. It's highly contagious to ordinary matter. If you were to somehow touch it, the extreme properties of this matter would infect you on contact. It would instantly dissolve your protective gear and immediately convert your entire body into a puddle of more strange matter. So down here, you don't just die. The fundamental building blocks of your very existence are completely rewritten.
Section 5. Creators of our world.
Okay, that is some pretty heavy stuff, literally and figuratively. So let's zoom back out into space for a second to witness the bigger picture. When neutron stars are born, they begin to spin incredibly fast, sometimes hundreds of times per second, like a celestial ballerina pulling her arms in. They generate the strongest magnetic fields in the universe, sweeping massive beams of radio waves through space. But the most vital role these stars play happens when they find a partner. When two neutron stars orbit each other, they radiate energy outward as gravitational waves, literal ripples in space-time itself. Over time, their orbit decays. This brings them closer and closer until they crash into each other in a catastrophic explosion, known as a kilonova. This violent collision spews their incredibly dense, neutron-rich guts out into the cold vacuum of space. And here is the most beautiful twist in our entire journey. As this super-dense, neutron-rich matter expands and falls apart in space, it quickly reassembles itself. This specific, insanely violent environment is the ultimate cosmic forge. It's exactly what's required to create the universe's heaviest elements. We're talking about dozens of elements here, including things like uranium, platinum, and yes, gold. So, the absolutely crucial point here is that stars had to die not just once, but twice. First in a supernova, and then in a kilonova collision, just to seed the galaxy with the very materials that we rely on every single day. Over millions of years, these elements drifted into giant cosmic clouds, got pulled together by gravity, and eventually formed planets just like ours. Which leaves us with this final thought. I want you to look down in a gold ring on your finger, or maybe the very technology you're using to view this explainer right now. The atoms making up those objects were forged in the heart of the most violent, extreme, and terrifying cosmic monsters in the universe. They traveled for 13 billion years through the dark, freezing expanse of space just to get to you. Kind of wild, right? Keep that in mind the next time you look up at the night sky. Thanks for joining me on this explainer, and keep exploring.